So there are three factors that can increase solubility, basically increase the ability for something to dissolve in water. Right, so those three factors are polarity, temperature, and pressure. Now, for the purposes of these notes that we were working on, we're just going to focus on temperature. Okay, the polarity and pressure, so things like if you add soap on your hands, that kind of helps get rid of solutions or dirt and germs off your hands. That's because soap and water are going to basically attract to each other and kind of bring it down or grab it and pull it away from your hand, kind of like unattach it. Okay, but if we go back to this, again, we're just going to focus really on temperature. So we'll go to our notes or handout that we're working on, and we're really going to focus on this page, and we're going to kind of just go over this graph first, and then we'll kind of start answering some questions together. So this is a solubility graph. Okay, and this is going to tell us how many grams of solutions or compounds, how many grams are needed to dissolve at certain temperatures, right? Because our x-axis is temperature. So as we increase temperature, what is happening to our solutes? So each line represents one solute and basically how it changes over time as you increase the temperature, how the solubility changes. So if we look at NH3, we can see as the temperature increases, the solubility for NH3 goes down, where we started at about 90 grams, which means in a 100-gram glass of water, about 90 grams of NH3 can dissolve in it at a temperature of 0 degrees Celsius. But as we increase the temperature, then we get something closer to around 7 or 8 degrees, or 7 or 8 grams of NH3, meaning only 7 or 8 grams can dissolve in a 100 grams cup of water. So here the solubility decreases as we increase the temperature. And it's important to know NH3 is a gas. Okay, so gases, we have one other one too that kind of goes down. If we look at cesium sulfate, kind of levels off, doesn't go as down as much as NH3 does, but that is also gas. So gases, as you increase the temperature, the solubility goes down. So we call this an inverse relationship, right? Because one is oppositely affecting the other. Increase the temperature, solubility goes down. But let's take a look at everything else. Okay, because if we look at it, most of the graph, most of these solutes are going up. Okay, so these are all solids. And as we increase the temperature of solute, the solubility is going to go up. So the rest of this handout, or the next two pages, really asks you to interpret this graph. And so we're going to run through a few of these together. So for any of these, for the first part, you have to find the mass of solute that will dissolve in 100 milliliters of water at the following temperatures. So if we look at potassium nitrate, our first one, first we got to find it on our graph. You can see it's right there. So at 70 degrees Celsius, how many grams of potassium nitrate can dissolve in it? So we got to go to our temperature side, find 70 degrees Celsius, go up the line, and we hit a point where they intersect right there. So then we have to go to our y-axis and see, okay, it's about 130 grams. Okay, so that's our solubility for potassium nitrate at 70 degrees Celsius. Our next one, sodium chloride. Let's just clean up the graph a little bit. So we have sodium chloride at 100 degrees Celsius. So again, you want to find the temperature first, or find sodium chloride first. So this one's a little hidden, but we can kind of see it right here. It's right next to potassium chloride. And we can see at 100 degrees Celsius that, if we go over, kind of want to try to see if we can get this straight. It looks like it's around 52 to 53. And that's what we will put in here. Okay, so ammonia chloride, the last one, make sure you can do that one on your own. At 45 degrees, let's just find it real quick. So ammonia chloride, there's that one. And at I almost did the wrong one. At 45 degrees Celsius, which is right here, we can see that it has about 48. Has a solubility of 48, meaning 48 grams of sodium chloride can dissolve in 100 grams of water. Okay, so we're going to clean this up again. We got some more questions to answer. All right, so this table here, we have to find each solution. We have to determine if it's saturated or unsaturated, and if it is unsaturated, how much more solute can dissolve in the solution. So our first one, a solution that contains 70 grams of sodium nitrate at 30 degrees Celsius. So first, let's find our solution. So we're looking for sodium nitrate, which is right there. And then we want to go to contains 70 grams. Let's first go to the temperature. So we have 30 degrees Celsius. So we're working with, go up here, looking at that guy right there. So we can see our solubility for sodium nitrate at 30 degrees Celsius is around 95, maybe 96. Let's say 96. So if it contains 70 grams of sodium nitrate, say you have a bag of sodium nitrate, not sure what you're doing with that bag, but you pour it in the water, is that enough to dissolve, or is there more space for sodium nitrate to be added? Think about the students and the desk. 28 students, 28 desks, 22 students, you still have more room. And in this case, we're only at 70 grams of sodium nitrate. So that means we can still probably add about 26 grams of sodium nitrate. So one, that means this is an unsaturated solution. And that means we can add about 26 grams to make it saturated. All right, we got to fill up those desks. All right, next one, a solution that contains 50 grams of ammonia chloride at 50 degrees Celsius. All right, so we're looking for ammonia chloride, which is right there, and at 50 degrees Celsius. So at 50 degrees Celsius, we are looking at 50 grams, okay? And here we have 50 grams. They just put in 50 grams. So that's exactly what our solubility is for this solute. So this is saturated. And so since it's not unsaturated, we don't need to answer that second column. All right, so make sure you answer those two on your own. Then a lot of these questions are very similar. You have to just find the solubility at different temperatures. So find the solute, line them up. But what happens if we have, say we're looking at potassium nitrate, and say it's at 30 degrees Celsius, and we put in 70 grams of potassium nitrate. That is above the line, where in the table we're dealing with unsaturated and saturated. This one was unsaturated, the sodium nitrate one. But this is an example of supersaturated, right? Because we have, in this case, about 22 grams more than the solubility of potassium nitrate at that temperature. So that's where we will start to see the solid forming at the bottom of the solution. Okay, that's going to go into some of the handout too at the end. All right, so hopefully that kind of addresses all of the ways to answer this graph. Think about saturated and unsaturated. Make sure you can read the graph properly. And if you have any other questions, let me know throughout the week. All right, talk to you guys later.